Hello everybody, today we're going to be evaluating the square root of I. So first of all, let's say z, some complex number, equals the square root of I, which is here. So then this implies that z squared equals I. Okay, very nice. So now let's try write this in its polar form. So for this we know that the radius is going to be 1 because z squared equals 0 plus 1i. So then we can think of this as a triangle with imaginary and real axes, and then of course on the imaginary we have 1, that's the imaginary part, and then we have 0 here. So this side is, the hypotenuse is simply going to be 1 squared plus 0 squared, and the square root of that, because it's the square root of 1 squared plus 0 squared. That's just Pythagorean theorem, which is just going to be 1. So we know that r equals 1. Now what about theta? Well, so what's the angle? So let's just plot our complex number. So we have, once again, imaginary and real. Well, we have 0 for the real part, so that's just going to be along here. And then for our imaginary part, we have 1. So our complex number is going to be right here. So what is the angle this makes with this line here? Okay, this is where we measure our angle from, and also we measure it counterclockwise. Well, it's going to be simply 90 degrees. So it's 90 degrees, well, we're going to use radians, so we're going to say pi over 2. But it could also be this angle here. Okay, it could be this other angle, which is going to be 3 pi over 2. So then, writing our complex number in the polar form, we get z squared equals 1, but this is just 1, so let's get rid of it, and it's going to be the cosine of theta, which is pi over 2, or 3 pi over 2. So let's just write it as pi over 2 right now, plus I times the sine of pi over 2. And now we're going to take the square root of this to find z. Square root, let's just write this as to the half. So now we get that z, which is our complex number, is the cosine. And now by De Moivre's theorem we can bring this exponent down into the argument of the cosine and the sine function, giving us pi over 4 plus I times the sine of pi over 4. Okay, sorry, this should be a negative 3 pi by 2, by the way. So we have this. Well, we showed that the angle could also be 3 pi by 2, so it could also be cosine of 3 pi by 4 plus I times the sine of 3 pi by 4. This is square root of 2 over 2. Well, these are the square root of 2 over 2. This is negative square root of 2 over 2. So, all in all, we get that the square root of I is equal to plus or minus square root of 2 over 2 plus, well, we can just factor out this. So this gives us 1 plus I, because we have square root of 2 over 2, this multiplied by 1, and we're being multiplied by I here. So finally, the square root of I, let's write this again, is equal to plus or minus the square root of 2 over 2 times 1 plus I. And that is our answer for today. So today we found out, using some complex analysis, that the square root of I is equal to plus or minus root 2 over 2 times 1 plus I. So, thank you for watching this video. Hope you enjoyed today and maybe learnt something new. Goodbye.